Hello class. Today we are doing Bluebook 6.4 and we're doing square roots today. Okay? From lesson 6, from exercise 6 to 14, we'll be adding and subtracting square roots. Let's take a look. On the first one, we have the square root of 2 divided by 9 plus 1/9. Okay? So what happens is you treat square roots similar to fractions. Okay, if you have a denominator, you keep the denominator just as you would in adding fractions. Okay, because these are fractions, it just has a square root in the numerator, so we keep that. Okay, and then we have the square root plus the 1. Because 1 is a square root and 1 is a whole number, they cannot be combined unless they're being multiplied. In this case, because they're only being added, we leave them as an addition problem. So it is the square root of 2 plus 1 over 9. And that is as simple as we can make it. Okay? So that we go from having 2 fractions to just 1. Okay? Let's move on to number 8, which is similar to number 6. Here, they both have 4 in the denominator, and so we have 1 plus the square root of 13. So here you have 1 plus the square root of 13, which will remain in the numerator, and 4 will be in its denominator. Okay, let's look at number 10. On number 10, you have 6 times the square root of 7 minus 2 times the square root of 7. Since they both are being multiplied by the square root of 7, then we will use the distributive property or a form of the distributive property in order to simplify this problem. Okay, so that what you have here on the outside of 7, you have 6, and on the outside here you have minus 2, and they both are times the square root of 7. So we simplify the coefficient numbers, 6 minus 2, which will give us 4 times the square root of 7. Okay? Let's look here. Here we have is understood to be a 1 where there's no number given on the outside of the square root here. So then we have a 1, and here we have a negative. We have a 1 here, we have a negative 4, okay, times the square root of 6. Therefore, 1 minus 4 give us a negative 3, and we keep the square root of 6. Okay? Here we have 7/8 times the square root of 11 plus 3/8 times the square root of 11. So once again, we do a form of distributive property so that we take the 7/8, okay, add it to the 3/8. They both are coefficients, and then they both were times the square root of 11. So now we can simplify what's in the parentheses. In this case, we have 10 over 8, okay? Now the square root of 11. Well, 10 over 8 can be simplified by dividing the numerator and the denominator by 2. Therefore, we have 5/4 times the square root of 11. We do not convert our improper fraction to a mixed fraction. We leave it as is, okay? Let's move on. From 16 to 24, we're simplifying the square root by finding 2 factors, okay, that can be multiplied with one of the factors being a perfect square. Okay, let's take a look at it. Here we have 18, so therefore we can use 9, which can form a perfect square, times 2. 9 times 2 is 18, so we have not changed the value, but we can pull out the square root of 9, which is 3, and we're left with the square root of 2. So it would be 3 times the square root of 2, which will simplify this radical. Let's move on to 12. Okay, what 2 numbers? One with the perfect square would be 4 times 3, and so therefore we can move the square root of 4, which would be 2, and we'll be left with 3 remaining under the radical. Here with 125, we have 25 times 5. Excuse me. Okay, and so therefore what will happen is we would take the perfect square of 25, which would give us 5, and we were left with the square root of 5. Let's look at number 22. Now, to simplify our understanding on number 22, we have the square root of 65 in the numerator and the square root of 121 in the denominator. We recognize that the square root of 65 would remain because we do not have a perfect square in 65 that we can simplify. Okay, so therefore it would be the square root of 65, but the 121, the square of 121 is 11. Okay, let's look at number 22 here. Once again, we're actually breaking this apart to the square root of 22 over the square root of c squared. Okay, therefore, we do not have two factors, which one of them being having a perfect square in it, so the 22 will remain under the radical, and then the square of c squared is c. Okay, that's our lesson for today. See you in the morning.